This is our Aquaculture and Greenhouse project. My name is Courtney.
Akeem. My name is Mark.
The goal is to reduce carbon emissions through aquaponics and improve the quality of greenhouses for plant production.
The problem was there were extreme carbon emissions and deforestation occurring across the world. To combat this issue, we created an in-class greenhouse to create a safe space to host plants.
So far, we have developed a prototype plan, created our pulley system, wired and coded our Arduinos, revamped our pulley system in our 3.2 prototype, attached our Arduinos to our bucket, created a solar panel circuit to power the Arduinos, and developed a greenhouse prototype.
So for our Arduinos, we use the temperature and water sensor. The temperature sensor's purpose is to accurately portray the temperature and humidity in the greenhouse, and the water sensor actively tests the amount of water that is detected in the plants on a number basis, with 0 being the lowest threshold. We use the DHT11 sensor, the LCD board for display, and the Arduino is used for control. In the beginning of our project, we decided to develop an aquaculture system which would host plants and fish, and that was our first experiment, which didn't go as planned. So we decided to revamp the project to just include aquaponics rather than adding fish. We developed the Arduino code to test humidity and water measures, which would sit on the side of the bucket. Well, the water measures would sit on the side of the bucket, and the humidity sensor would be on the side of the greenhouse to measure the humidity inside the greenhouse. A gear configuration pulley system would be used to raise and lower the plants for our aquaponics system. The in-class greenhouse will host our aquaponics system and any other plants that we would decide to create. And then plant germination was used to create different plants such as chia seeds, lavender, and mint. So this slide has pictures that show the progress of our project. In the top left is showing us doing the germination process as well as a prototype of the greenhouse. We also have students who are working on the greenhouse who went to go visit UDC to learn more about aquaponics and plant production. And then in prototype 3.1 on the top right, it shows our pulley system, which will help lower and raise the plants, as well as our solar panel system, which will help charge the Arduino. That will be used on the side of the bucket as well as on the greenhouse. And you can kind of see the Arduino on the side of the bucket, which is the water sensor. And then prototype 3.2 incorporates the greenhouse, the bucket, and the solar panel. We attach the solar panel to the side of the greenhouse, which will allow it to charge the humidity sensor and the water sensor. And then we put the bucket inside the greenhouse because that would be ideal for our plant production.
The prototype had begun as a small plastic box to replicate a greenhouse. Now, the greenhouse has become scaled larger to accommodate the 5-gallon bucket and the Arduino features we have created. The prototype had to go through 2 phases to achieve the results wanted. The Arduino now can successfully handle the code and libraries implemented and can show the temperature and humidity inside of the greenhouse.
With more time and resources, the greenhouse would be larger in size, had better plastics to trap more heat, a better solar panel, better wiring to charge the batteries more efficiently, better motors to move the gears more efficiently, so we're wasting less energy with the batteries. No holes in the bucket. We would also make the resistance on the Arduino's LEDs less, so the LEDs are lighter, brighter. And that's it. And for our acknowledgments, we would like to thank
Circuit Basics, Arduino.
Our teacher, Mrs. Stemple.
and UDC students and staff.
Thank you.